Hello and welcome to this video brought to you by Smart Exam Resources. The idea is to help you understand how to solve questions for the alternative to practicals, that is paper 6, also called as the ATP exam. This will help students of physics for both the 0625 and the 0972 students. In this video, I shall explain to you question number 1 from May to June 2020. The question is based on measuring the period of a pendulum. Today's objective is to help you understand how to measure the period of a pendulum, and then how to perform some more steps, in order to find out, if at all, other chosen factors have any effect on the period of a pendulum. Also, I shall not read out the question word by word to you. What I will expect you to do, is to keep a copy of the paper with you and read the question before you begin watching the video. Also, since it is an alternative to practical exam paper, I feel you need to have a soft copy with a stylus pen so that you can complete the paper on your devices. Else, you need to print the paper and keep a construction box and a pencil with you, so that you can complete the question manually. In any case, you are free to simply watch the video and understand if you prefer doing just that. So let's begin. Now I have created two versions for each page. The one to the left is the original question paper. The one to the right has the answers mentioned. So, with this in mind, let us begin. The experiment here is about a student who is investigating the period of a pendulum. The apparatus includes the bob, which is tied to a string, which is suspended from a clamp. Also, as we can see, there are two images. The one to the left shows the bob in the rest position as it is exactly below its point of suspension. And in this position, the length of the string is d. The first part A of the question is asking us to draw a diagram, and then explain how you would measure d accurately by using a meter rule and a set square. Now before you start drawing, first ask yourself if you know the uses of each of the apparatus that you need to use. So the meter rule is used to measure the length of the string. Similarly, the set square is to be used to ensure that you are able to take the correct value from the scale. Also, your line of sight should be perpendicular to the scale being read, at the position where the set square is pointing. Since you have been asked to draw and explain, so, kindly go through the explanation that I have written. So, the first part was to test your understanding on using the apparatus correctly. Now let us read the B1 part of the question. It says that the student has set the value of the length of the string as 50 centimeters, meaning the value of d is 50 centimeters. She has then displaced the bob and then measured the time t1 for 20 complete oscillations. Also, for the sake of reference, there is a diagram that will help you understand what one complete oscillation means, just in case you have forgotten. In B1, there is a stopwatch that is showing this time t1, which as you know is the time for 20 oscillations. Now you need to write the time shown by this watch. As you can see, the stopwatch has 3 units, 1 is the minutes, next, the seconds, and last is 1/100th of a second, which is also called as the centisecond. Yes, that's called as centiseconds. But nobody really uses this word much. I explained this to you, so that you know that 1/100th of a second means a centisecond, so the time as you can see is 28.12 seconds. In the part B2, we have been asked to calculate the period t1, which is the time period of a single oscillation. This we can find by dividing the time period of 20 oscillations by 20. Note that small t represents the total time for a large number of oscillations and capital T represents the time for one oscillation, that is the time period of the pendulum. In the part C, the student has adjusted the length of the pendulum to 100 centimeters. She then notes the time for 20 oscillations and also calculates the time period. Both these values have been written in the part C. Now, we can see a topon balance on which the bob has been placed, and we have been asked to note the mass of the bob, ma to the nearest gram. The mass shown is 51.65. But since we have to write the mass to the nearest gram, we shall then write it down as 52 grams. In the part D, we have been asked to compare the four time period values, namely, T1, T2, T3, and T4, and then tick the best possible option that we agree with, keeping in mind that the results are within the limits of experimental accuracy. To answer this question, it will help to quickly make a table containing the values of D and T for each mass of the bob. Creating a table will help us make a fair conclusion. So here I have created a table already for you. So when the mass is 51.65, the value of D was 50 centimeters and the time period was 1.406 seconds. When the mass is kept the same, and the value of D was increased from 50 to 100 centimeters, then the time period changed to 1.99 seconds. Next, only the mass of the bob was changed and the length was kept as 50 centimeters as before. It was found that the time period was 1.39 seconds. And finally, for this new bob, the value of D was changed to 100 centimeters, and it was seen that the time period was 2.02 seconds. It is obvious from this comparison that the period stays the same when the mass of the bob is changed, provided the length of the string is kept constant. The small differences that you can see in the time period are within the limits of experimental accuracy and hence can be ignored. This means that it is only the value of D that affects the values of the period of the pendulum. So we need to tick the first option. The justification is that for the pendulums of different masses, the values of the time period are 1.406 and 1.39 seconds. A similar comparison can be made for the pendulums of different masses for a string length of 100 centimeters. The small difference in readings is within the limits of experimental accuracy. In the part E, the student is trying to investigate if the size of oscillations has any effect on the period of the simple pendulum. In the part E1, we have now been asked to draw a diagram, where we would be able to find the size of the oscillations. We could find the size by measuring the angle between the equilibrium position and the extreme position on the pendulum. I hope you know that the equilibrium position is the position in which the pendulum is exactly below its point of suspension. So we could find the size of the oscillations by aligning the 90-degree mark on the protractor with the equilibrium position and then reading off the value on the protractor that coincides with the string at the extreme position. This value is the size of the oscillation. Drawing a diagram is not necessary. But I have drawn it for you. Please do refer to it. In the part E2, you have been asked to state a variable that could be kept constant while changing the size of the oscillation. So, now, from the earlier part, since we have concluded that a change in the mass has no effect on the period of the simple pendulum, and what does affect the period of the pendulum, is the length of the string. So obviously, we would keep the length of the string constant in the part E2. Also note that the reason we keep other variables constant is to ensure that our readings are not affected by these other variables. So well, we are done with solving question number 1 from May to June 2020, paper 6-2, in which I tried teaching you about measuring the period of a simple pendulum, in an alternative to practical paper. So, as you must have seen, it is important to read with understanding. It is also always better to jot down a few key things or even make a quick table, like the one I drew earlier. So rather than looking at an alternative to practical paper like another theory paper, try to get into the shoes of the experimenter and the process of answering the questions becomes a lot simpler. Also, you must have realized that if you want to prepare yourself with the concept of period of a simple pendulum, then you also need to possess the skill of drawing related to reading the value of the length of the string, measuring the amplitude of oscillations, etc. At the same time, you need to be able to make quick tables to help you draw better conclusions. Reading the weighing scales along with the rulers is also essential. So through this video, I have tried to make you understand how to be better prepared for the ATP exam for this topic. So, well, that's all in this video. And, yes, do subscribe to our channel to get regular updates on new videos. Thanks for watching. God bless.